This is our last section in Chapter 4 and our last topic with congruence in triangles. Section 4.6 is congruence in right triangles. Remember, the hypotenuse is the longest side of a right triangle. It is opposite the right angle. The legs are the two sides of a right triangle that include the right angle. So in our triangle ABC, side AC is the hypotenuse, and our legs are BC and AB. The HL theorem, or hypotenuse leg theorem, says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, in our first two examples, it says, are the triangles congruent by HL? If so, give the triangle congruent statement. So remember, in order to use the hypotenuse leg congruence, we have to know that our triangles are right triangles, that we have a pair of corresponding congruent hypotenuses, and a pair of congruent corresponding legs. So in number 1, we see that our two triangles are right triangles. We have angle C and angle I, both have right angles. Side OW and side PN are our hypotenuses, and they are congruent, and we do have one pair of congruent legs. So yes, these two triangles are congruent by HL. My congruent statement would be triangle COW is congruent to triangle INP. Okay, in number 2, we have two pairs of congruent sides. They are corresponding, however, we don't have any angles, and in order to use the hypotenuse leg theorem, we need to have a pair of right angles. And we cannot assume that angles A and Y are right angles. We have to be told that, or we have to be told that we have perpendicular bisectors. So in number 2, the answer is no, and that's because there are no right angles. Number 3 says triangle XYZ is isosceles. From vertex X, a perpendicular bisector is drawn to YZ, intersecting YZ at point M. Explain why triangle XMY is congruent to triangle XMZ. Alright, so let's first draw an isosceles triangle. And it says our vertex is X, so that means the top point's X. Here's Y, here's Z. It's isosceles, so I know my two sides are congruent. It says that there is a perpendicular bisector from X down to YZ, intersects at M. So I know that I have a right angles. And since it's a bisector, I know that it makes ZM congruent to YM. Okay, so why is triangle XMY congruent to triangle XMZ? Well, we're going to list a few things here. We know that XZ is congruent to XY because it's an isosceles triangle. Whoops. Okay, and that's the isosceles triangle theorem that tells us that the two sides are congruent. We also know that ZM is congruent to YM, and that's because XM is a perpendicular bisector. And lastly, we know that angle XMZ and angle XMY are right angles. Again, that's because XM is a perpendicular bisector. Okay, and that's enough information to prove the two triangles are congruent by the hypotenuse leg theorem. All right, let's look at an example of a hypotenuse leg proof. So in number 4, we are given that angle ABC and angle DCB are right angles, and that AC is congruent to DB. We want to prove that triangle ABC is congruent to triangle DCB. So let's first write out our givens. So we have angle ABC and angle DCB are right angles. And AC is congruent to DB. So those are given. So right now we do have a pair of right angles, and we have one side congruent, which happens to be our hypotenuses. So we just need a pair of legs that are congruent. Okay, similar to our last triangle proofs, we see that side CB is shared by both triangles. So I can say that side CB is congruent to side CB by the reflexive property of congruence. And now I have enough information to say my two triangles are congruent by the hypotenuse leg theorem. So triangle ABC is congruent to triangle DCB by the hypotenuse leg theorem. Okay, next examples says for 5 and 6, tell whether the hypotenuse leg theorem can be used to prove the triangles congruent. If so, explain. If not, write not possible. All right, so in number 5, we are told that side AC is congruent to DC. So those would be our hypotenuses because we have right angles, angle CBD and angle CBA. And then also because of the reflexive property, we have a leg that is congruent. So the answer would be yes. And if I had to explain, I could say AC and DC are hypotenuses. Angles CBD and angles CBA are right angles. And BC is congruent to BC. And there are legs. So just make note of that. And actually, we know AC and DC are congruent and they're hypotenuses. So yes, in number 5, we could prove the two triangles are congruent by the hypotenuse leg theorem. Okay, in number 6, we do have right angles. Angle RET and angle WEQ are right angles. We have two pairs of congruent sides. However, we do not know about our hypotenuses. So we could prove these triangles are congruent, but it would be by side angle side, but the directions asked whether we'd be able to prove they're congruent by HL. So the answer is no, and the reason being we don't have congruent hypotenuses. Okay, and we're done with those two examples. For 7 and 8, it says, what do you need to prove the triangles congruent by the HL theorem? So number 7, we're looking to see why triangle LMX, so this triangle here, is congruent to triangle LOX. Let me use a different color. All right, so we do know that LX is congruent to itself. We are given our pair of right angles, but we do not know about our hypotenuses. So the piece of information we are missing is whether or not LM is congruent to LO. If we knew that, then we would be able to prove the two triangles are congruent by the HL theorem. Okay, number 8, we want to prove why triangle AMD is congruent to triangle CNB. Okay, so what piece of information are we missing? All right, we have right angles. We have our hypotenuses congruent. But the question is, we don't have a leg. Are either of our legs congruent? So there's more than one answer here. We could either be told that side AM is congruent to side NC, and we'd be good, or side DM congruent to side NB. We would need one of those pairs of legs to be congruent. Okay, here are our last examples for this section and for chapter 4. It says determine which triangle congruence theorem proves the triangles congruent. If they are congruent, write a congruent statement. If not, write not possible. So now we are thinking of all the theorems that we have done in chapter 4. So that's side, 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 angle, side, angle, side, angle, 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 side, and finally HL. All right, in number 9, let's see, we have two pairs of congruent corresponding angles and one pair of included congruent sides. So these two triangles are congruent by angle, side, angle. Then my triangle congruent statement would be triangle NYT is congruent to triangle JWS. Let's see, in 10, we are given a pair of congruent corresponding angles, a pair of congruent corresponding sides. We see our two triangles share the side AL, so it's congruent to itself. And these two triangles would be congruent by side, angle, side. So we can say triangle ALE is congruent to triangle LAP. Let's see, in 11, we have right angles. Our hypotenuses are congruent, and we have a pair of legs that are congruent. So these two triangles will be congruent by the HL theorem. Our triangles aren't marked, so we don't have to write a triangle congruent statement. All right, in 12, we have a right angle at angle ANO, so that would make angle ANM also a right angle. We are given that angle M is congruent to angle O, and our two triangles share the side AN, so that makes it congruent to itself, and therefore these triangles are congruent by angle, angle, side. Our congruent statement, the triangle AMN, is congruent to triangle AON. See, in 13, well, we can say that AD is congruent to itself, and that's about it. We don't know anything about AD, if it's a bisector or anything. We don't know if we have parallel sides. So 13 would be not possible because we do not have enough information. All right, 14, we have a line that's shared by both triangles, so that's congruent to itself. We are given one pair of congruent corresponding sides, but we don't have any angles. And we can't assume that our line in the middle is a bisector or is perpendicular. So we can't assume that we have right angles. So 14 is a not possible because we don't have enough information. All right, and this concludes our last section in Chapter 4, and it concludes our triangle congruence proofs.